This video is to demonstrate and document the small project that I created based on the integrity part of the CIA triad using PowerShell and FIM process. So when we talk about integrity, it involves the trustworthiness of a data, and it's one of the very important parts of cybersecurity or security in general in terms of IT. When we talk about FIM, which is like the file integrity monitoring, it's basically a security IT process which defines and alerts when there's a data which is corrupted or data which is tampered with in an operating system. It can be in files, it can be in any part of your basically home computer. So this, which you see around here, like it's a basic flowchart of what the project is about and what we go through in this whole project. And yeah, but while talking about what happened in this project, first, when we design this project, initially the user is asked about what the user wants to do, in which there are two options. First, it creates new baselines. So this new baseline means that everything that is existing in a file that you want to protect or you want to monitor. I can give you an example of what I use. So this is basically what I've used in this file. So this whole document has 4 files. They are currently empty. These text documents have nothing, as you can see. And then we basically first collect the hash values of these in the A column. So as soon as you create a hash value, it defines, okay, there is something which exists, and the moment it changes, you have to get alerted. How does this happen? So after creating the hash values, which happens here, and it is basically saved in the files, which when we do the process and when we go through the program, I will show you during the demonstration. And then when the user clicks B or selects B, that's when the monitoring of the file starts to happen. So the first thing which happens is basically when you start monitoring, the baseline.txt, this is where our hash values, the original hash values are saved. This is what it loads. The system loads the hash values, and at this point it starts to go and then loop and compare. So the moment I change something in this file, so if I change something in 1, 2, 3 or 4, any of these documents, it will give me an alert. And the alerts are systematically mentioned in like 2 or 3 ways, which we will also define in the program, which is like when the file is changed. So when you add something, when you delete something from this file, in the text column, currently it is empty, so let's say when we add something, it will give us an alert. When we change something in the text, it will give us an alert. The next is, which is a high priority and basically which compromises the integrity, as it's a small demonstration of how it affects the whole file, is when the file is deleted, there will be a larger alert which says, okay, the file is deleted, and now the security person, the SOC analyst, or anyone who's working on this system or taking care of the system gets the major alert that, okay, there's something wrong, you have to check on it. This is basically the code. We'll go through each function. If you're interested in watching the raw footage or raw video of me typing the whole program and basically going through licks and picks and some trial and error, there's a second video which you can watch as well. Feel free to also skip this part if you are not interested in knowing what each function or what each part of the program does. And if you want to just look at the demonstration, if you want to look at what this code does, you can skip to the part and you can watch the demonstration. So the first part which we do when we assign or when we design this code is basically defining a function where we calculate the hash of the file. So in this part, we also use a trial and catch format in this because it's also important to make sure that there's no errors. And the moment when you start coding and when you run the whole file, to run the whole code, it will give you points where there are errors. When it is for the program there is something wrong, which then it doesn't get to calculate the hash of the file. So this whole section is basically defines the calculate file hash that takes a file path as a parameter. Here, which you can see inside this function, it attempts to calculate the SHA-512 hash. So it's basically one type of hash. There are many. You can use 256, you can use 512, and there are many others. You can decide which one you want by using the get file hash. So this, which you can see, that's what we use. And in this process, if it's successful, it returns the hash. So it will store the hash, and if there's an error, it will basically print here in this form that, okay, there's an error while calculating, or if there's an exception, and then it will return the value null. The next part is when we define a function to erase the baseline. So usually when you will run this format, every single time that you run the code, it will just keep printing the same baseline, the same hash file over and over again. So to make sure that it doesn't happen, this is the function that we use. So in this section, we define a function which is erase baseline if already exists, that checks if a file named baseline.txt exists already in the current directory. And if it already does, then it removes and basically replaces it, which is done when we do in the third function. So in this function, we basically define a function to read the baseline data from the baseline text file into a hash table. This is something which is optional. I just made it to make the code a bit more presentable, a bit more presentable, to make sure that it has more things. But yeah, it's completely optional. It's not necessary. You don't have to. But when you are coding a bigger project, this will be quite helpful. And the reason why I have a lot of indentations is here is to make sure that the code runs perfectly. Indentations in general is really important when you code. It defines which function has to run at what particular time and that it does not overlaps. So here in this function, or in this section, it defines a function get baseline. Here, what you can see, that reads baseline data from the file name baseline.txt into a hash table, as I mentioned before. Now we initialize an empty hash table called baseline. In this, then it checks if baseline.txt exists using test path. Here, there's the if statement. And if the file exists, it reads the content and splits each line into a key. That is file path and value, which is hash. Using the split here, we basically then add them into the baseline hash table, which we will see when we do the demonstration, how the hash table looks like. And then finally it returns the baseline hash table in this. The next which we go through is defining the function to update the baseline. So here in this section we define a function here, which you can see, update baseline, that tasks and takes a hash table here as a parameter. So the parameter baseline, which we define up here, that's the parameter it uses. Then it uses the get enumerator. It's the method to iterate, you can say, through the key value pairs into the hash table, which is, as we define up here in top, which is both the value and the keys, which is basically your file path and hash. And for each pair, the last line where we define for each pair, it takes the key and the value with a separator, that's the separator, and appends it to the baseline text using the out file. So this out file it uses to basically append and to make sure that we don't have continuous hash files, but only just one for each. Now this whole section is basically what you see in the command prompter. I can show you. So this is basically what your command prompter is, and here is when you see all the output and all the demonstration. So this is where it will show you what has to be typed, what the user sees, and basically asking the user what they have to do, in which you can either choose the option A or option B, which has set definitions. Write host is basically like print function, which everyone might know about. It basically prints the whole text, which is in the connotations in the command prompter. And then read host, this basically reads, or this is where the user, it is used to capture the user's input, and then it is stored in the variable response. This is basically, you can define it yourself. It's not necessary that you use response or anything. It's just something which I used. The next is now when we go into two different if cases or if else cases. And we will see what happens when a user clicks A or selects A and when the user selects B. So this first is where like the if statement of when the response is equal to A, and it itself explains that this code checks if the user response, which is stored in response, is equal to A when converted to uppercase. So this basically defines that even if a user inputs the lowercase a or an uppercase a, doesn't matter, like it will just make it uppercase A and store it in the response and check. So this part just is to make sure that there's no uppercase or lowercase issues. You can choose not to make it more concrete and just say if it's only uppercase, then this response is equated, and if not, then it doesn't, or it shows an error. And then we go through the erase baseline. It again calls the erase baseline if already exists, which we define this function, which we define up, to remove the existing baseline files if it exists, which is also important, as we already mentioned, that we don't want to have our hash values repeatedly in this file stored. Then the file equal to get child item, this line is basically used where we initialize an empty hash table named baseline, which will be used to store the baseline data. So now after we have, in general, in this term, erased the baseline, which is we erase the hash values, we then now create again a hash value and then store it again in the baseline. That's what we use by using this for each statement, and this basically iterates through each file in the $files list. This form or this line of the code is used to call the calculate file hash function to calculate the hash of the current file. And this current file is basically all the files that we have stored. And then it's stored in the hash, this variable. Then this whole statement is basically to check if the hash variable is not equal to null, which is that it has something stored, indicating that the hash calculation is successful. And then it goes to the next part where it adds an entry to the baseline hash table, where the key, which is the file path, and the value, which is the hash of the file, is stored. And then it basically again calls the update baseline function to update the baseline file with the new baseline stored in the $baseline hash table, which is again, it just repeats the process. Now we go through the else if response of how and what happens when the user selects or types B. So in this statement, this code, or this line of the code, basically checks if the user response, which is stored in $response, is equal to B, which is again to upper, which is like to make it not case sensitive. And then it basically starts monitoring the files which are saved. So this is the start of the file monitoring. Now, this line of the code, it calls the get_baseline function to load the baseline data from the baseline.txt file into the hash table name file hash directory. So now, when we can see we are in this part of the flowchart, where it starts monitoring by loading the file hash pairs, which is what is saved from the baseline.txt. Now we go into the different while loop, which is in this, like, it starts an infinite while loop. This loop will continuously monitor files as long as the script is running. So this is basically defined whenever you start this program, whenever you start running this program, which you can see here. Whenever you start doing this, it will just start a counter, and it's an endless loop, as I have not mentioned anything where it says it has to stop at a certain point. It's basically something which goes on till the user itself, or if you can say the analyst himself, decides to stop the program, stop the whole program from running. And that's here, like in this, how it's defined, that it pauses the script execution for 1 minute using the start sleep. So this is basically used to introduce a 1 second delay between iterations of the loop, which is so that it prevents the consumption of the CPU, that it's not consuming too much power, and that basically there's every single second there's a pause, so for the computer, for the CPU. This code uses the get child to retrieve a list of files in the file directory, which we also define up before in our function, and then it stores them in the hash file variables. This is again something which, this path is basically which you have to define it yourself. It's the name of the file path which I have defined. It can be anything else. It can be whatever name that you wish to name your file. But as for me, the file name is files. That's the reason why I have this path here. Then, when we go to another for each, in this it starts a for each loop to iterate through each file in the $files list. So the files, whichever are stored, now it creates a loop to check. In this function, or in this line of the code, it calls the calculate file hash function to calculate the hash of the current file and store it in the hash variable. Then we check if the hash variable is not equal to null, indicating the hash calculation was successful, which we also do the same process when a user clicks A. Then afterwards we go to another if statement and pay attention to the indentations to make sure that everything here, as you can see, it goes, the process goes accordingly, and that it does not overlap, and that you don't have this logical exceptions where it won't show an error but the program doesn't do what you actually want it to do. So in this, if the hash table contains the file path, it compares the stored hash value with the newly calculated hash. If they are equal, it means the file has not changed and nothing happens. So this does not create any alert, and this tells the analyst that okay, everything was working smoothly, there's no problem. If they are not equal, it means the file has changed, and it displays a message to the console indicating the change in yellow text. So this basically defines the color of the text. I use this to make sure that you see that there's a change, and it's like a medium alert which the analyst sees that okay, there has something changed, and it is like shown, which we will also see in the demonstration. Then the other case which we here define is if the file path is not found in the hash table. So basically there's a new creation. If there's a new file which is created, it displays the message indicating that the creation of the file, there's a new creation of the file, and it's in green. So this is a normal message which tells the analyst that okay, there's a new file created, and that the user is basically working on this file. This can be an issue as well if the intended file is not to be tampered with, not to be changed at all, the whole directory. Then it can be, but it's not necessarily an alert. That's why it's shown in green. You can choose your color as well. It's not necessarily has to be this color. The script continuously monitors the file in the files directory, checks for changes or creations, and provides feedback based on the saved base. So this basically keeps on running. Then when we go to this terms, this function and this line extracts all the keys, like all the file paths from the file hash dictionary hash table, and stores them in the baseline path variable. Then when we go forward, this initializes an empty array named baseline path to remove. This array will be used to store the file paths that need to be removed from the file hash dictionary. So this also is something which is basically to create additional cover for your code. Now this line or this whole function, what it does is it starts a for each loop to iterate through each file path in the baseline path array which we stored, and then it checks if the file path does not exist in the file system using this test path. So this function or this is used, and also use the not operator because it negates the result, so it evaluates to true if the file does not exist. Then if the file path does not exist, which means that the file is deleted, it displays a message to the console indicating the file has been deleted. And this, most of the cases, here when you can see, is a big or integrity compromise, which means that the file which was intended to be in this directory is now deleted, it does not exist, which means the hash file or the hash value of this file does not exist, and now it gives a big alert to the analyst that, okay, something has gone wrong, someone is trying to get into the files and trying to delete it or tamper the whole program. Now, when we use this loop, so this for each loop is, in this section, it iterates through the baseline path to remove array, which contains the file path of deleted files. It uses file hash directory or dictionary dot remove, so this function, to remove each of these paths from the hash file directory. So this is when there's the file is deleted, it also deletes the hash value from the baseline.txt to make sure that, okay, it does not create any integrity problem again. And at the end, when you use this update baseline, this is basically a function to update the baseline file with any changes made in the file hash dictionary. So basically this updates everything, ensuring that the baseline reflects the current state of the monitoring file, accounting for any deletions. So the moment there's a deletion, it will come out of the loop, it will update, and then it will show that, okay, there's a deletion and now the file only contains 3 files, or 2 files, or no files, based on how much files it exists. And then it tells the analyst that at this moment there are only 3, and then it creates a new baseline text. This was about the code, what was designed in this project. As I mentioned before, you can also watch the second video where I go through and then I type the whole code and through trial and error and trying to understand basically which works, which doesn't work, through making sections of run selection and seeing if it works perfectly or not. Now we can start the demonstration of this whole code, which you see here. Now in this, first, as our file is stored, we go to the directory, which is in projects. Now, as you can see, we have the files and we have the also the directory where this file section is stored. Now we can basically run the whole code. Where you can see this is the code, runs the whole code, and now it asks the user, what would you like to do? Do you want to collect new baseline or begin monitoring the file? First, when we do this, when we collect the new baseline, I can show you here in the project, there's the baseline created. So this baseline contains the file path and the hash values of everything that exists in this directory. You can click and see there's the separator, which shows where this file exists. As you can see, all the files and the corresponding hash values for the same. So if I do again run this program and click A again, you can see that here in the baseline there's no, it doesn't create it twice. So it works. What we did here, that initially we create a new baseline and the path here which tells that if there's a baseline which already exists, make sure that it's deleted and we create a new baseline again. But as it will be the same as we didn't make any changes. Now we run the program again and now we click B. So now we start beginning our monitoring. Here you can see, let's say this file, and the first text file, I change something, I save it, and there's the alert which you see in the command prompt saying that, oh, there's a the file has changed, there's something you have to look for it. It comes back to its original place. I save and the alert stops. You can see the same for 2. I save with changes. There's the alert again, which starts showing that, in the second text, there's something changed, and there's the medium alert created. Now, when it's back to its normal state, there's the alert which stopped. Now, if let's say I create a new text file, and let's name it fortify or something, and then I create it into the file. In the directory, you immediately see there's another alert, which is my minor alert in green, which says, there's a new file which is created. Now if I remove this file back, the alert stops. The reason why there's no big alert saying that there's the file is deleted or the file does not exist is because while we are running this program, it has stored this initial baseline of files having 1, 2, 3, and 4, and not 45. That's why if you remove this, it does not show you that the file is deleted. It just stops showing the alert that there's a new file which is created. Now, for an example, let's say we remove this file, or basically delete this file from this path. There will be a big, or the main integrity compromise alert, which shows that the file has been deleted. And at this point, the program stops. It gives the analyst the information that go look at it, that there's a problem, and there's the file has been tampered with, and there's this, as it's a red, or how we define the color red, that it's the big alert, that it's the big problem. Let's go and check. And at this point, the file or the command prompter shows this error, or shows this alert. And now what you can also see is, if we go back and put the 4 again, for an example, it will just show that a new file is created. It won't show that. The reason behind this is because once this 4 is deleted, when we see this last point here, update baseline, it basically updates the whole hash. And in this, you will see that it only has now 3 and not 4. And because of this, it does not show you, it shows you that there's a new file created and not shows an alert saying that file 4 is restored. Because usually when a file is deleted, it's really hard to restore. So that's the reason why I designed this program this way. You can also do it in different ways, and basically there's an endless possibilities of doing this project, doing this demonstration. You can play with the code every single time which you want. You can also in general make it more nicer, or like have more information pass through. But as I only had designed it this way to basically demonstrate this whole flowchart on what happens, that was the task that you could see. This was about it for the demonstration of the algorithm hashing using PowerShell and FIM process. I hope this was interesting to you. Feel free to try different things if you want to. Feel free to look at the code and make your own demonstration. And you can also look at the second video, as I mentioned, again, where you can look at the raw footage of me going through the whole program. where I type it and have some running sections to see if it works or not, and basically at the end designing the whole program. Yep, thank you.